Welcome everybody to the Urban Ecology Collaborative, our February 2023 meeting. The Urban Ecology Collaborative is a group of municipal officials, nonprofit organizations, and researchers, primarily in the Northeast and Mid-Atlantic regions. We meet on the third Wednesday of each month to discuss issues related to urban ecology and urban forestry. Additionally, I have a couple announcements for today. One is that we are looking for another co-chair. So if you're interested in co-chairing the Urban Ecology Collaborative, please reach out to us at urbanecologycollaborative@gmail.com. It's really fun and rewarding. You get to meet a lot of really cool people across the Northeast and Mid-Atlantic. We've been super grateful to David Mechelon from Speak for the Trees in Boston for his awesome work since January of 2021. Co-chairs generally serve a 2-year term, and it's nothing too intense, but we would love to, I think, get some beyond Boston co-chairship going on. So if you know someone who would be good for this, it's a really great opportunity, and we are looking for another co-chair. Also, due to the shifts over, I think I'm going to update the Zoom link for next time. So anyone who's looking for the join link, if you're looking at old emails, it'll be different as of I think March 2023. So keep an eye out for new Zoom join information. So today we are super excited to have Professor Joy Winbourne share her research. She's going to give a talk titled Nature-Based Solutions to Climate Change. And I will do a little introduction to Joy, and then she'll share her screen, and we can learn some great things. So Joy is an assistant professor in the Department of Environmental, Earth, and Atmospheric Sciences at UMass Lowell. Dr. Winbourne is an ecosystem ecologist and terrestrial biogeochemist. Her research is focused on understanding how plants and soils regulate the movement of carbon, nutrients, and water in terrestrial ecosystems under a variety of human perturbations. In particular, she examines the impact of urbanization, deforestation, forest fragmentation, and climate change on terrestrial ecosystem processes. Her research agenda is motivated by the need for actionable ecological data and theory to inform sustainable environmental policies and evaluate their efficacies, especially in the context of global climate change. To address these research aims, Dr. Winbourne integrates field studies, remote sensing, meta-analyses, and modeling approaches to scale the ecosystem processes at the individual soil core or tree to landscape scales to uncover trends in key services ecosystems provide human societies. Prior to joining UMass Lowell, Professor Winbourne was a postdoc research fellow at BU and a Voss postdoctoral fellow at the Institute for Environment and Society at Brown University. She holds a PhD in ecology from the University of California at Davis, and Joy is going to share about a couple of super interesting projects. First, on drivers influencing the extent to which urban vegetation can help cities combat extreme temperature through evapotranspiration, and the second on the influence of urbanization on carbon dioxide fluxes from urban vegetation. Thank you for being here, and take it away, Dr. Winbourne.
Awesome. Thank you so much for that wonderful introduction. I'm gonna share my screen and get some slides up. Awesome. Well, thank you for the invitation to share with you all today some of my research. If you are interested in hearing more, please check out my website, which is in the slide deck for those who are interested in checking it out. Before I get started, I always like to start off with acknowledging everybody who made this research possible, because science is extremely collaborative and it takes an entire team. So I just wanted to acknowledge all of those who have been part of the research that I'm going to be presenting today. So as Erica mentioned, my research is really motivated to understand nature-based solutions and when, where, and if they are the right solution in the right place. And so when I think about my research, I kind of focus on kind of 3 main areas, 2 of which are kind of looking at understanding nature-based solutions, understanding the fundamental ecosystem processes and the biogeochemistry of ecosystems and how we can leverage that knowledge to better optimize and implement strategies, both in the mitigation, which is more focused on how can we store more carbon on land. So a lot of my past research has focused on restoration of tropical forests and the role of nutrients in limiting carbon uptake, especially during regrowth. And what I'm going to talk to you today about is kind of my other 2 branches of research, one focused more on the adaptation aspect of nature-based solutions. And both focused more on cities. So cities represent a rather small area of the land area on Earth, but they produce the majority of our greenhouse gases. And are where the majority of people live. And so adapting to the impacts of climate change and urbanization are something on the minds of many in cities. And in particular, cities are going to be stressed by heat, increased heat, because as the climate is changing, we're getting an increase in the magnitude and duration and frequency of heat waves. And cities are proposing one strategy towards mitigating heat is increasing canopy cover. And another branch that I'll talk about in my research is more on the carbon fluxes component of understanding the role of the biosphere in getting accurate estimates of CO2 fluxes. We often think of cities and think of the anthropogenic CO2 emissions, which is the majority of the emissions. But as this picture of Boston demonstrates, there's a lot of plants and a lot of soils, and they're moving carbon as well. And understanding those fluxes spatially and temporally is really important to developing monitoring systems that will allow us to know if we're meeting our goals of decarbonizing our cities. So that's just kind of a big overview of my research interests. And I wanted to also start off by kind of defining what we mean by nature-based solutions. It can mean different things to different folks. So I just wanted to kind of present the way I think about it, which is this idea that if we can protect and restore and manage or create natural ecosystems, that we can leverage all of these benefits. In particular, greenhouse gas reduction is one, cooling and shading, which I'll talk a lot about today. Another big one for cities is, especially in the Northeast here, I'm in Lowell, in Massachusetts, is floodwater mitigation from increased precipitation events. And I'm really interested in understanding the net effect, because with each of these strategies, there's also some disservices that vegetation and soils can provide too. So really interesting kind of exploring the net services that urban vegetation provides. And I also always love to start off by emphasizing that it's one piece of the puzzle, right? Nature-based solutions is not gonna solve climate change or solve all of the issues. We have to be focusing on social solutions, which is reducing our emissions in the first place, and also technical solutions, because climate change is already at our doorstep. And so the timeline in which we're working, we need to start thinking about kind of integration of both technical, social, and these nature-based solutions. But as Erica mentioned, I'm trained as an ecosystem ecologist and biogeochemist. So a lot of my expertise is on understanding carbon, water, and nutrient cycling between plants and their environment. So my research is really interested in focusing on kind of the nature-based solutions and when they're the right solution versus something else. And the first part of my talk, I'll talk about kind of looking at adaptation, the role of greening in cities for adaptation to extreme heat, which is happening both because of climate change, where global average temperatures are rising, heat wave frequency, duration is rising, but also cities have been observed to be hotter on average than adjacent rural areas. And so what's known as the urban heat island effect is happening synergistically with climate change. So a heat wave in a city is much more negative and increase in temperature than just outside of the city. And lots of cities are proposing to increase canopy cover as a way to make their cities more resilient to heat. It's one of many strategies. And we know that trees can cool the environment through these kind of two main mechanisms. Shading, which seems kind of obvious, like if you sit under a tree on a hot day, it blocks that radiation, especially blocks it from hitting you, but also that darker pavement that's often underneath the tree. That's then going to re-radiate that incoming radiation as heat. But even more importantly is the amount of energy that plants consume evaporating water. So plants during photosynthesis, they take in carbon dioxide to make sugars, but in the process of letting CO2 in, water vapor leaves. And so plants move a lot of water from the ground up to the atmosphere. And during that phase change, it goes from a liquid to a gas and evaporates. and it takes energy to do that. So it's what's called the latent heat flux. It has a cooling effect because of that consumption of energy. And so studies have been done kind of demonstrating that, for example, a 20% increase in canopy cover can reduce local air temperatures by more than 5 degrees Fahrenheit. And this is just one example kind of demonstrating that we know that more vegetation tends to correlate with lower temperatures. This is a study done in Arlington, which is just north of Boston, done by a graduate student, Sarah Garvey, who is looking at this relationship between surface temperatures and canopy cover across different classifications of that canopy cover type. So panel A is showing kind of the city of Arlington and the different types of canopy you have there, parks versus street trees versus more residential areas or open land. And panel B is satellite derived data that can tell us what the land surface temperature is at pretty coarse resolutions. The best resolution you can get is typically like 30 meters, which is pretty coarse for an urban area. But when you look at the relationship between those two, panel C, you see that when there's more canopy cover, you have lower surface temperatures, which is a good thing. So we know that this is something trees provide, but what really motivates my research is kind of understanding the nuances of, what is controlling these transpiration rates. As someone who studies plants, I know that plants have different water use strategies. Depending on where they're growing in the city, they might have different water sources that they're getting. And their environment, how they're responding to their urban environment might influence their transpiration rates. And so the figure on the right here is just kind of a conceptual figure kind of illustrating the heterogeneity that we have in cities in regards to environments that plants are exposed to. If you're a street tree, you have a much higher heat load. You have a smaller tree pit, there's potentially less water going into that tree pit, but you also might be getting water from leaky infrastructure, especially in old cities like Boston. That's a thing that's known to happen, is that our infrastructure is kind of leaky. Or what's the management that's happening, how much irrigation, which depending on the climate conditions, we don't want to waste water. So understanding where trees are getting their water from and what's controlling these rates of transpiration, both in response to urbanization and climate change, is a question that has really been motivating my research in this recently. And when I got started working on this years ago, I went to the literature to be like, who's measuring transpiration rates at the tree level? And this is a bar graph just kind of illustrating the number of studies that I found, which were many. There was only about 44, and a lot of them, there was a lot of overlap. Like those 44 also include like 5 studies that did same trees, 5 different outcomes. So number of trees could be lower. But yeah, the left panel is kind of what was the motivation of that research. And a big part of it is water use. Especially in arid systems and with increased kind of dry heat waves, we're really concerned about maintaining our urban vegetation for these services. And then also the cooling that comes from that. Those were big motivations. And then the right panel is just showing like, where are we doing this work? Mostly in parks and also on street trees, some in forest patches. But often we're doing it where we have access to kind of line power, which is usually on a more managed area. And part of that's because to measure transpiration at the tree level, you use sensors called sap flow sensors, and they can often be really expensive or difficult to make. So I think that has kind of led to the reduction in the number of studies we have in the cities. And so I've been working with Taylor Jones, who developed this really great sensor that is much more affordable, pretty easy to make and assemble. It uses the world's tiniest chainsaw to install it, which is really fun, and shown in panel C here. And it uses an approach known as the compensation heat pulse approach, where you use heat as a tracer. So kind of the middle set of sensors here is spitting out heat, and then there's sensors that are measuring the temperature and the movement of that heat. And by measuring heat movement, we can make other measurements of how much sapwood is there, how deep is it, to get at total transpiration rates by the tree. And this probe, one of the big advances of it, there are several, was different than before, is that you just make one slot into the tree using this tiny chainsaw instead of having to make multiple holes, which look great on the front, but we did it in the lab and used a drill press, and it looks great on the front, but then on the other side, it's, the distances on the other side can be all over the place. So it helped reduce some errors and is fully calibratable. So we've calibrated it in the lab, which is shown on the right here. And we keep making advances to it. The idea is to make it pretty affordable so that we could create a network of sap flow sensors in cities and really start understanding transpiration rates across this heterogeneous landscape that we have in cities and the relationship between how different species are responding to their urban environments. And so just to present one example, we deployed these sensors in sugar maples that we're growing in Boston. And that's going to be, I'm going to show you the data for those urban trees on the right panel. And then we also worked with a group that measured same species of similar size, measured sap flow in a rural forest outside of Boston. And I'll show you the data for that on the left panel. But here we were interested in what is the relationship between sap flow in a city tree versus a canopy tree that's getting, top of the canopy, getting lots of light, just like our urban tree is, but has lots of neighbors and it isn't experiencing that urban heat island effect and maybe has more limitation because it's not being managed and irrigated or fertilized. And what is the climate sensitivity of sap flow between these two sites? So on the x-axis, I'm showing the daytime mean air temperature. And how does that change when a heat wave comes through? So in our rural site, we saw very little relationship between sap flow, which is kind of a proxy for transpiration, and the average temperature. And the points are showing the solar radiation coming in. The color of the points is telling you solar radiation, and the size of the points is showing what's known as vapor pressure deficit, which is basically how dry is the air, to just demonstrate that those two are quite variable too, and it's not just because there was a lot of cloudy days and that was driving them. And in the city, and the red hashed line here is just showing kind of the cutoff point for what we consider extreme heat events is on the right side of that red line, based on kind of looking at max temperatures in the summertime. And in the city, oops, there we go. We saw a really strong relationship, quite the opposite, where sap flow was very sensitive to air temperatures and continued. What was really interesting when we saw this plot of data was the continuation of transpiration rates on really hot days. So those days that are to the right of that red dashed line, where they keep transpiring water, which is actually counter to how we think maples tend to behave and how our models kind of predict transpiration rates. We predict that at really hot temperatures, stomates should close because they're losing more water and might cavitate, so they close their stomates when it gets really hot. But in cities, we manage our trees and irrigate them, or maybe they're getting extra sources of waters here in the Northeast, and so we keep seeing that transpiration. And we were interested in kind of understanding the implications of this finding of kind of the impact of irrigation or not on cooling effect of vegetation. And so we worked with an urban climate modeler, Dan Lee, to kind of play around with these parameters in a modeling space. And so here I'm showing some of the results from that model simulation. And on the y-axis is Bowen ratio, which is showing the ratio between sensible heat flux. So that's all that solar radiation coming in and hitting pavement and re-radiating as heat. That's your sensible heat flux. And the latent heat flux, which is the role of vegetation, evaporating that water and creating that cooling effect, and looking at the ratio of those two. Across simulations that varied in canopy extent. So on the x-axis, we kind of played around with how much canopy there was. And then the bars, the color of the bars are showing, did we allow for irrigation in the model? So no water limitation, assume the trees are not limited by water, or do we assume water limitation? And it's just whatever the ambient availability of water is in the system. And what you see is that there's a couple of cool findings. One, canopy extent, as you have lower Bowen ratios, more latent heat flux as you have more canopy cover, but you also have these higher Bowen ratios when there is no irrigation as well. And we also looked at the surface temperatures in the model to kind of look at the impact on the temperatures being experienced. And this was all run during a heat wave as well. And so the differences between these different simulations, well, they are just a few degrees, which might not sound like a lot, a few degrees of Celsius. Those during a heat wave can have profound social health impacts. And so we see really large differences between the irrigated versus not irrigated at these different canopy extents. And the other thing to kind of point out too is this is using one of the common urban climate models, but in that model, that green vegetation is parameterized or represented like a grass. So there's a lot of room and improvement in our models to represent urban vegetation and the type of vegetation, because trees and grasses behave really differently in their transpiration rates. We know this, and probably are responding differently to their environment. And the implications of this too, on kind of human behavior, one that I've been hypothesizing and excited to test is this potential positive feedback loop that then develops, where if you have really hot temperatures during a heat wave, if transpiration is stopping, which is what we theorize, and could be the case if the trees are more water limited, we'd see a reduction in that cooling latent heat flux, which would lead to the increases in local air temperatures and have the potential to increase the dependence of urban dwellers on air conditioners that produce a lot of waste heat into the environment, at least the current air conditioners that are commonly used. And that will further increase air temperatures. But if trees are continuing to transpire water during heat waves and aren't shutting down as we theorize, this would have the opposite effect. It would create more of a negative feedback loop where more increase in latent heat flux, that cooling flux, could help to reduce local air temperatures and reduce our dependence on air conditioners that produce a lot of waste heat into the environment. So kind of future research directions I'm excited to take this research in is, how do transpiration rates vary among different species? So I just showed you data for sugar maples, but we know species like oaks have very different water use strategies than maples. So how does that vary? And how are these transpiration rates responding to these extreme weather events? So heat waves in general, but also a wet heat wave versus a very dry heat wave, and how are transpiration rates responding? Are some directions I'm really excited to take this research in. So in the time that I have left, I'm just going to share with you another branch of my research that's focused more on developing tools to help cities decarbonize and reach their goals of decarbonization. And this research has been going on down in Maryland, outside of DC. I've been working with collaborators at the National Institute for Standards and Technologies, where there's an initiative to develop standards around the different tools and develop new tools to monitor greenhouse gases in urban areas. And so on the campus, there's this really beautiful forest patch that got left behind when it was previously agricultural. And so it's a 100-year-old tulip poplar forest that we've established a number of experiments to understand greenhouse gas fluxes in urban forest environments, which are often fragmented. So we've set up this plot on the forest edge so that we can understand also the impact of forest fragmentation on carbon cycling dynamics. And we've heavily instrumented this plot to measure all sorts of different CO2 fluxes with the goal of understanding And this is just a picture on the ground kind of demonstrating the instrumentation happening here. But our goal is to document what the CO2 fluxes are in an urban forest, which to our knowledge hasn't happened before, and see how good our models that we commonly use for estimating CO2 fluxes are for capturing these fluxes. And so when we think about CO2 fluxes in kind of an ecosystem context, our goal is to get at that net ecosystem exchange of carbon dioxide. And that's a product of the gross amount of CO2 being fixed by the primary producers or the vegetation in the system, and subtracting out your respiration, ecosystem respiration, which is all your CO2 losses to the atmosphere. And so we did this in this 1 hectare forest site by making loads of measurements, as I mentioned, on these trees. So we measured photosynthesis at the leaf level that we scaled up to the whole canopy. And we made measurements of respiration from the leaves and the stems and the roots. We did experiments to kind of parse out soil respiration into the autotrophic and heterotrophic pathways. And you can kind of see it over here on the far right. We have lots of soil collars on the ground measuring soil respiration, one of the main CO2 fluxes leaving ecosystems. And we also compared it to different model using different satellite data. So it's a common model used in urban environments, the vegetation, photosynthesis, and respiration model, which is an empirical model that uses satellite-derived data for looking at things like greenness and water status of the system. And I won't go into a lot of detail about the model, but please feel free to ask questions at the end. But this is just showing you that we ran it using different satellite data products that are at different scales. So the MODIS grids are red, and the Landsat grid, which has less temporal frequency, but has much higher spatial frequency, is at 30 meters. And I'm going to show you data from running it using the Landsat data products. And so our modeled data is on the y-axis here. And the x-axis is that forest inventory of all those measurements on the ground that we were making across these different components. So panel A is showing ecosystem respiration, which is all those lost pathways of CO2 to the atmosphere. And the 1-to-1 line is that dashed red line. If the model perfectly described what we were observing, it would fall along that line. And for respiration, the model over predicts, assuming our on the ground estimates are correct, it over predicts respiration in the winter time, which makes sense because this model is estimating respiration based on a temperature relationship. But it does a really surprisingly good job at gross ecosystem exchange. Those points could fall along that 1-to-1 really nicely. And then looking at the net, which is panel C. And so this work has kind of highlighted a lot of areas for model development that we're starting to pursue. But another thing to just kind of end here with this kind of aspect of my research is putting it into the larger context of incorporating all of the CO2 fluxes, which also includes sources from fossil fuels, and looking at that seasonally. So here I'm showing our CO2 fluxes on the y-axis, and each panel is a different time of the year, looking across an entire day, but showing the fossil fuel fluxes that are happening in this area because of people driving their cars around and heating buildings and things like that. That black line, as you would predict, kind of goes up as people go to work and goes down as people go home. And that's happening throughout the year and is much higher in the wintertime when we're heating our homes, right? But what's really interesting is looking at that net flux, which the red dark line, there's, especially in the summertime. So gross ecosystem exchange or taking up of CO2 from the atmosphere by the vegetation is so significant in the summertime that it actually kind of offsets some of the fossil fuel emissions that are happening during that time period, emphasizing the fact that if we're developing monitoring systems we need to really understand vegetation dynamics on carbon fluxes, especially in the summertime, when vegetation in the Northeast is really active, in order to partition those fluxes properly. So with that, I'll take any questions. I think I've left plenty of time, hopefully. I'm keeping an eye.
Yeah, thank you so much, Joy. So interesting to see your research. This is super exciting stuff to get at these different relationships. I'll start with a couple of questions from the chat. The first one was, these are some great graphic slides. Would you share them?
Oh yeah, definitely. I can share. I can send you my slide deck.
All right, great. So we'll share those out to the group after the call. And we always post these on YouTube as well. So we'll send out the link to the recording for folks to watch.
Awesome.
The next question that came in while you were talking was, what kind of power source does the sap flow monitor that you developed need?
Yeah, so the reason we went with what's known as, there's several different techniques for measuring sap flow, and one requires line power. So I think that limits its use. So we went with an approach that uses batteries. Currently, it's running off of like a kind of relatively cheap lead acid battery, and it's pulsing the heat, so it doesn't consume as much energy for that reason. So yeah, battery powered.
Awesome. I think that was the last question from the chat, so I'll open it up. Anybody in the room have questions for Joy?
Hi, I had a question about the last slide that you showed. So on the winter, I think it was on the winter, the net flux and the fossil fuel were about the same. Why was that? You explained why it was for summer, but I was interested in why net flux and fossil fuel were approximately the same in the wintertime.
Yeah, that's because in the wintertime, vegetation here, that gross ecosystem exchange, that blue line, is basically zero.
Oh, okay.
And ecosystem respiration, soils still respire, and
Okay.
the model kind of over predicts how much they're respiring in the wintertime. And so it's a small contribution. That's why the red line is, so basically the flux is dominated by fossil fuels in the wintertime, with like it being elevated even more so by respiration from soils.
Okay, gotcha. Thank you.
Great question. And I see from Karen in the chat, would you please explain the Bowen ratio in more detail?
Oh yeah. What is that? That is not a good noise. I think that's a fire alarm. Seriously? Uh-oh.
Oh no.
Do y'all hear that?
We can't hear it, but if you need to run.
Oh, that's a fire alarm. Yeah.
If you have to go, Joy, I'm happy to kind of facilitate the end of the discussion. Karen says she can email you.
In my slides, which I'll send, there is the publication, which I explain it a lot more. Yeah, sorry.
It is totally okay, Joy. We'll stay on for a few more minutes without you.
Okay.
Good luck. Okay, so as Georgina says, LOL, life happens. That is definitely true. I did share Joy's website and a link to the Google Scholar where you can see Joy's research. But otherwise, I would love to still hear other folks' other questions. If other people have thoughts on evapotranspiration or some of the things Joy covered, feel free to come off mute and we can have a little discussion.
Hi, Erica, it's Philip. How are you doing? I'm just wondering if others on this call are engaged in research projects like this, if they are working with local researchers or university partners to do studies as incorporated or part of their work.
Hi, this is Colleen. I can respond, Phil. Good to see you. We are working right now with researchers on a study in New Haven and also for the state in partnership with DEEP here, our Connecticut Department of Environmental Protection, that's focused on urban heat island and canopy cover. And actually, I think one of the researchers is on this call today, or was. Maybe they left. But anyway, so yes, we are.
Excellent. Yeah, we'd love to see more interaction with universities, local community colleges, projects, put people to work and explore and document what we're doing on the ground in cities.
Yeah, go ahead, Georgina.
Yeah, we haven't, we're just starting to explore this at New York City parks, but there's a lab at CUNY Grad Center that's looking to install sap flow sensors in some of our parks. They are using like some massive battery that they're gonna have to like bury in the ground to hide it from interested people. So I'm really interested to hear about this different technology. And I'm going to try to connect them with Joy. But yeah, they've been doing work in Alaska, and now they're interested in kind of looking at how it's different in an urban context. So. Oh, and then I just have to also say that the Natural Areas Conservancy is kind of piloted, not exactly the same, but looking at air temperature monitoring in natural area forests, and their partner, the Forest and Cities Partnership across, I think it's 12 cities in the United States. And so that's comparing temperature anomaly data that's remotely sensed with on the ground measurements that are like in a forest versus a street tree versus a landscaped area tree, to try to understand if different land cover types confer different cooling benefits. Of course, it's not my study, so I'm kind of representing it, but there has been a lot of press about it. So if you wanted to learn more, I recommend contacting Clara Pregatzor.
Excellent.
Great question, Phil. Yeah, and fantastic. Clara is like, I'm always looking for her name on these different presentations because I'm so curious to learn more. I just wanted to mention what Ashley said in the chat. Thank you for this, is finding ways to get more young people engaged in field monitoring. So I know Baltimore has a lot going on there. I know that like Philly, PowerCore Philly and PowerCore Boston, which is modeled after that. I would love to see that kind of reaching into this space of more like applied research, and then how that can inform some of the more, I don't know, like landscapey type things we try to get folks involved in. I feel like there's a lot of room to get young people involved in urban forestry GIS and getting them involved in like real rigorous like research studies, rather than just saying like, the youth can go water the trees, which is fantastic as well. But also, involving folks in more kind of what you think of for college level, like climate research. I think that would be really great in some of the places I work. And I see a couple more things in the chat. What is PowerCore? Good question. So PowerCore, it is spelled with a P. I see the two different spellings. It is sort of, I think, maybe there's other people on the call who can describe it better than I can, but PowerCore Philadelphia, I think, is maybe one of the starting ones, if I don't have that totally messed up. But Boston modeled their PowerCore in the past year after PowerCore Philly, and it's an opportunity for folks who have been kind of marginalized from the urban forestry sector to get paid and learn the urban forestry space. Sometimes it involves green infrastructure or urban farming as well. There's maybe different tracks that individuals in the program can take. At Mass Audubon at the Boston Nature Center, we partnered with the first cohort of PowerCore Boston this year, and they're helping us with restoring our southern boundary. We have development kind of encroaching, coming up right to our border on our site. So they're helping us remove invasives, but also reforest and monitor an entire section of our property. They're also going with other organizations to other places. And I see, Karen, thanks for putting the PowerCore Philly link in the chat. Sorry, Phil, I didn't mean to interrupt you. Go ahead with what you were.
No, that's fine. And I see a question about citizen science, which I think we're now calling community-driven science. Is that what, I don't know what new language we're using around that, but many of the opportunities for funding, I think, through NOAA and their heat island studies, but also now with this Inflation Reduction Act funding that'll probably be coming out at the end of the month. You can perhaps, with local community colleges and universities, you can apply for grants to do community-driven science and other studies. So things to think about as we enter into this new phase of funding for urban forest activity.
Totally agree, Phil. Yeah, the grants are really interesting. And on the language, that's a conversation I've been having with our environmental fellows recently is it community-driven science? Is it I've been using participatory science a lot. That's what the EPA has recently, I think, been using. And the reason I've been doing that is that at the Minneapolis, the first annual Women's Forest Congress in October, there was a presenter from I think it's University of Minnesota. I'm not really familiar with the names of the universities out there, but it was from their extension program. And in their presentation, the presenter said that community science or community-driven science would involve community members or be started by community members at every phase of the scientific inquiry. So community members would be involved in formation of the question, formation of the research methods, the data collection, the results, analyses, and the dissemination of the results, which sounds like a lot of work. But I think some of the things that we've been trying, at least at Mass Audubon so far, have been more along the lines of participatory science, where, we're trying to kind of do some of that digging through the literature and say, here's a method that could be accessible, and then people are participating in those methods. So I think community-driven science is really cool and a really big opportunity in this space. Like a lot of other folks in the chat, I think are. And someone mentioned at the beginning being excited for the City Nature Challenge. I'm interested to see how urban forestry and the City Nature Challenge can interact, because it is all taxa, but I think the urban forest is supporting a lot of that. So that is a great one coming up in the spring. And then, yeah, if anyone else has thoughts on the community science or citizen science aspect of it, I'd love to open it up to other folks while I read some of these other chat messages.
Yeah, I mean, people, obviously all of you are involving the public in the work you're doing, and engaging with local researchers might help frame some questions to engage your participants in, and further the learning that you do on the ground. It's more and more people want to get involved in what you do because of all the press that we're getting around carbon and cooling and life-saving impacts of the work we do as we plant and care for trees. So kudos to all of you in that work. It's a great time to be in urban forestry.
So true, and such interesting comments coming in the chat. If you're able to see the chat right now, Pat, thank you for incorporating this kind of One Health approach. Pat's question is, as a wildlife veterinarian, I'm curious to know if biodiversity and urban wildlife is being incorporated in urban tree canopy and urban ecology projects. I can definitely say that from the Mass Audubon, kind of Massachusetts, smaller scale urban perspective, I'm so interested in this, and I think it is kind of, I've been thinking of trees and urban forestry as like a keystone or a gateway taxa for folks who care about trees already, but might not be as into the wildlife ecology aspect of it. Is urban forestry kind of like an entrance point for them? Do they already have the urban wildlife? And then, urban wildlife is their entrance into urban forestry. What do others think about the wildlife connections here?
Hello, my name's Neha. I entered something in the chat. So I'm a wildlife ecologist at Parks. And I wrote that, we do consider the habitat value of urban trees, but often have to balance the considerations with other things that make it difficult to survive, for trees to survive in street trees. So oaks are really great habitat providers, but so are some other trees. I know that there are some people that have commented in the past about using ginkgos in New York City and how that doesn't really provide habitat value, but it provides other values. So it's like, with trees, I think there's a lot of balancing of the different priorities. But I'm also curious about your question, Erica, about how urban forestry or urban trees can be a kind of a gateway to thinking about like a mosaic of habitats in a city. Not just trees, but also meadows or wetlands. I'm an amphibian person, so like that's really important to me. But yeah, I think it's like, I like your idea of a gateway. But I'm also curious to hear what other people think.
Yeah, hi, this is Pat Klein. Nice to meet you all. This is my first event and webinar, so my pleasure meeting all of you. And yeah, the comment about deer control. So wildlife are both for the benefit and also, unfortunately, for the detriment. And so even in my own local town, the browse line issues, right? So you're trying to build these healthy forests, urban forests, or ecosystems, and you do have issues with having to control some of the wildlife as well. So that is just kind of built into this balance that I know you're trying to establish. And what we're calling in my local town is, sort of urban forest restoration. There's been so much non-native invasive plants that have come in that have taken control, have, caused problems at one end, including the deer. So there's a balance, as you know, in nature. So, but having done some of that work, having done some of the deer control, and actually NIST, somebody mentioned, I think our speaker was talking about NIST, that's a campus that's not far from actually where I live in Maryland. And I know they've done a lot of work over the years with deer control many years ago because they were having similar problems. So just the sense of the holistic approach, I think, is what I was asking about. As much as I've learned a lot about, ecosystems and forestry for my own professional and personal reasons, it's building the system that brings those wildlife back, whether it's nesting birds, amphibians, and turtles. I heard somebody talk about that. That's part of the result that I think your goal is not only to make that a desirable place for humans and create those, sort of heat shelters, but that also provides shelter for the native wildlife. So just kind of building that into the discussion and using that in a way as a metric to see part of your success is not only do you get better canopy, less invasive plants, maybe control the deer if you can, given Lyme disease and everything else, but also you see return to native wildlife while you see a return of other portions of your ecosystem. So I hope you can build that in at some point. Thanks for the opportunity.
Thanks so much, Pat. Go ahead, Stella.
Good morning, everyone. I have a terrible head cold, so apologies for the sound effects. I wanted to respond to the question about trees as the gateway drug to nature, because I think we've actually been funded by the Washington, D.C. Urban Forestry Division to do neighborhood tree walks. And we're piloting it out as a series to engage people with their trees and their local nature on an annual basis. So through each season, we take them to admire and look at the trees in a particular season. So a lot of street trees, but also yard trees that we might see. The reason I'm bothering to bring it up is because, well, first, we love the support from our UFD. And they're really wonderful supporters of our work. And also because I've started the most amazing conversations about insects standing under an oak tree. And we have these great photographs of people with their jaws dropped as they gaze up, looking at the canopy, listening to the katydids and hearing about the stories of the insect populations of oaks. So we definitely can confirm that in our experience as a nature nonprofit, trees have been a fantastic introduction, and the forestry division's support for that work has supported not only their work, but ours. So I think it's a great approach. I hope we can do that all over our city, and then you have a chance to do that throughout your metro areas.
Thanks, Stella. Great to hear about. Fred, go ahead.
So, at Tree Baltimore, so we run our Tree Keepers program to instruct people, and one of the core parts of our introductory course is literally trees and wildlife, where we bring in someone from Baltimore Green Space. So it's the intro for people, I mean, ultimately to go out and plant or prune trees, and primarily street trees, but we try to incorporate everything in the intro the whole urban forest. And so part of that is getting that connection, and then bringing in a partner, in this case, Baltimore Green Space, to talk trees and wildlife, is a way to get people who might have been interested in the program from a different perspective and get them involved. And often there's this cross-pollination between the tree keepers and the street trees and the other green organizations, and with our natural resources team. So that's, I think, a big bonus, and I love that.
That's some excellent biomimicry with the cross-pollination between organizations, but also the pollinators that use some of these trees. Joy mentioned that forest being a tulip poplar forest. I think someone else said that they also really love tulip poplars. I just did some structural pruning on a tulip poplar this morning, so very coincidental. But yeah, what types of trees we're using, that's come up a lot in my work recently with the Northern Institute of Applied Climate Science putting out kind of a climate vulnerability assessment and regional species selection guide. So making sure that the trees we're planting now, and this is kind of an unformed idea, so sorry for not having the concise words, but the trees we're planting now, if we are urban forestry stewards that are doing the planting or deciding on tree species, there's kind of the One Health of now, and also the One Health of like 100 years from now. And maybe they're not totally different, but with climate change, I think thinking about just like what is going to benefit the wildlife populations that we have now, but also like those aren't the only ones, and humans also have things that are happening. That's been swirling around my mind a lot, especially as the native invasive, those conversations come up. I saw a talk the other day by Nina Basuk from, I think, Cornell, if I'm not messing that up. And it was really interesting perspectives on like how we think about native invasive plants, ecosystem change, benefits to humans, but also, yeah, that whole holistic approach of other things. Thank you so much for coming, Colleen. Have a good day. And then I see some folks putting some great things in the chat today, cool things about climate adaptive plants. I love that we were able to take this kind of fire alarm evapotranspiration situation and turn it into a great conversation.
Yeah, maybe we could get one of our University of Delaware scientists to speak to us about insects and wildlife. I know Vince D'Amico there, and of course, who you mentioned, Cornell, Travis, what's his name? Trammell. What's the science? There's a lot of researchers out of Delaware that could probably give us a great presentation.
Great. Well, that's a great segue, Phil. We'll build that into the lineup. So again, we're looking for a co-chair for the UEC. So if you're interested in organizing speakers and adding people to the list and recording the meetings and kind of co-facilitating, let us know. Or if you know a student who might be good for that, or someone else who you can think of. And maybe we can host a discussion and sharing session. Yeah, we have done that before. We've been calling those roundtables, and I think people really enjoy them. We usually kind of put together a set of guiding questions and send those out before those meetings. So I'll look for a space in the schedule for a roundtable and some kind of guiding thoughts there. It's always a great group. Thank you everyone so much for coming today, and we'll look forward to getting Joy's slides out, answering some more questions that were in the chat, and seeing you all again in March.
And have we figured out how to post these on our website, these videos?
We actually have. I've been tinkering around with the website a little bit, making some small improvements here and there. More of those probably to come this month. We do have a YouTube channel that's it's taking off. We are going to be world famous for urban forestry discussions. So check out our YouTube, and I'll send out all the links after this meeting.
Wonderful. Thank you. Great conversation.
Thank you so much, everybody. Have a great rest of February, and thanks for coming, and we'll see you next month.